Hello and welcome to the presentation of this master's thesis project, which has been done under the course of Industrial IT and Automation on University of Southeast Norway. The topic of this presentation is to follow a trajectory for a sea drone which has used MPC as a controller, and on the way to follow its trajectory it will try to avoid any collision with any obstacle it faces. And ROS is used here to collect sensor data in gazebo. So here is the content of this project, or in this for this presentation we will be discussing what are the problems solved, what are the technologies used, and implementation and results. So what are the problems solved? So main objective of this project is to follow a trajectory, or in a simpler version we can go to reach a target which will be given to the control system. Second objective would be to avoid any obstacle on its way, and third objective is to follow call rate rules. The technologies used in this project are MPC. This is the mathematical model of the sea drone which has been simulated in gazebo, and this is the cost function which reduce the distance between the current state and target. Kasadi is also used to solve the optimization problems. Python and ROS is used to code the whole algorithm and to solve the problems. Finally, gazebo is used to simulate and test. Implementation and results. So these are the few constraints that has been considered when designing MPC. The prediction horizon was 10 steps and the step size was 1 second, which matches with gazebo simulation. The system overview is similar to other control system, where plan and guide module passes the target to control system, and based on that target, states has been considered and control are submitted to the USV, and sensor data is again collected and passed to plan and guide module. Software architecture is simplified to this flow diagram, where it starts and then it checks for target, which is if it's reached or not. If it's not reached, then it will check the obstacle on its way, and then it will also check the rules, whether it can pass or it has to give away. Then it updates the temporary target based on the obstacle to pass the obstacle. When the obstacle is passed, then it will be updating its temporary target again. So this loop will be going on until it reaches its final destination. So in this implementation, VRX model is used in gazebo. The sensors are used very common sensors, which is GPS and IMU, and finally the control is done through thruster topic, which is applying force. A bit snippet from the code. This is the main while loop, where the break is happening only when the target is reached. These are the callback functions of ROS topic, and here are some settings of Kasadi solvers, and also design of cost function. And here is the implementation and the result of the experiment done. On the left side, it's showing the path of the USB moving without any obstacle, and the right side shows the path of USB moving while having obstacle. And finally, other two scenario has been tested in this project. One is multiple objects and multiple obstacles, another one is moving up. That is all for this presentation, and thank you for your time.